All right, welcome to The Explainer. Today, we are diving into a piece of tech that feels like straight up magic: noise-canceling headphones. Seriously, how do they create that perfect, quiet little bubble for you in the middle of a noisy world? Well, let's find out.
Okay, so here's the game plan. First, we're going to tackle the problem itself, all that noise. Then we'll look at two totally different ways to solve it. One is like putting up a shield, and the other, well, it feels like magic. We're going to pull back the curtain on how that magic really works, and then we'll get to the final verdict on this whole quest for silence.
So, first things first. Let's talk about a problem we all know way too well: the nonstop, unwanted noise of everyday life. I mean, think about it. The roar of a jet engine, the constant rumble of traffic, the buzz of an open office. Our world is just plain loud. And that leads us to the big question, right? How in the world does a little device you wear on your ears manage to just erase all of that noise and give you your own little pocket of peace? The answer isn't actually magic, it's physics. So how do you even begin to fight back against all that sound? Well, the first solution is the most obvious one, the one you'd probably think of first. You build a physical shield. Think of it like a fortress for your ears. It's our simplest line of defense. Now, this has a name. It's called passive noise cancellation, or PNC for short. There are no fancy electronics here, no batteries, nothing. It's all about smart physical design. We're talking thick, dense materials, super comfy air cushions, and a really tight seal around your ear that physically blocks sound waves from ever getting in. And you know what? This simple shield is actually really good against certain kinds of sounds. It excels at blocking those higher frequency noises. Things like the click-clack of keyboards or the sharp sound of people talking nearby. But, and this is a big but, this shield has an Achilles heel. It's not so great with low-frequency sounds. Those deep, constant rumbles, like from an airplane engine or the hum of an air conditioner, they can vibrate right through that physical barrier. To stop those, we need something a whole lot smarter. And that brings us to the real game changer, the tech that feels like pure magic: active noise cancellation. See, instead of building a wall to block sound, this approach does something wild. It fights sound with more sound. So unlike its low-tech cousin, active noise cancellation, or ANC, is a super smart electronic system. It's basically a little team of components working together in perfect harmony. You've got tiny microphones that listen to the outside world, a powerful little computer chip that thinks about that sound, and speakers that then act to completely erase it. Okay, so how on earth does this tiny electronic team pull off a trick like erasing sound? Let's break down the science behind the so-called magic, because it's both ridiculously simple and absolutely brilliant at the same time. The entire secret comes down to a really cool physics principle called destructive interference. So picture this. Every sound is a wave with peaks and valleys, right? Ups and downs. Now, what if you could create a second sound wave that is the exact mirror opposite of the first one? So for every peak, it has a valley. Well, if you play them both at the same time, they completely cancel each other out. And the result? Silence. And get this. This whole four-step dance is happening thousands of times every single second inside your headphones. So, step one. Tiny mics on the outside are constantly listening to the ambient noise. Step two, a digital signal processor, the brain of the whole operation, analyzes that sound wave. Step three, that processor instantly creates the perfect mirror opposite wave, what we call anti-noise. And finally, step four, the speakers inside your headphones play your music plus this invisible anti-noise, and poof, the outside world just vanishes. So now that we get the science, let's talk about how this all plays out in the real world. We'll go over the different kinds of ANC out there, how well it actually works, and we'll tackle that big question a lot of people have: is this stuff even safe? Right, so it turns out not all ANC is created equal. You've basically got three main flavors. There's feed-forward with mics on the outside, great for constant drones. Then there's feedback with mics on the inside, which is better at adapting to sudden changes. But the gold standard, the top-tier stuff you'll find in the best headphones, is hybrid ANC. It uses mics both inside and out to give you the best of both worlds. So what's the bottom line? What is ANC really good at? Well, think of it as a specialist. It is an absolute master at wiping out those low-frequency constant sounds, like an airplane hum.
But it's not quite as good with sharp, sudden, unpredictable noises like a dog barking or someone shouting, mainly because it's just harder for the processor to react and create that perfect anti-noise wave in time. This leads us to a really, really important question, and it's one a lot of people think about. If your headphones are creating more sound to cancel out noise, couldn't that be bad for your hearing? It's a totally fair concern.
And the answer might just surprise you. It's a big no. In fact, ANC can actually be better for your hearing in the long run. See, that anti-noise isn't adding more sound pressure to your ear, it's neutralizing the sound pressure that's already there. And because it gets rid of all that background noise, you don't have to crank up your music to hear it, which means way less strain on your ears overall.
You know, the team at Uplatz really summed it all up perfectly. They said ANC is smart physics combined with fast signal processing. It's not magic. It's just an incredibly clever and elegant use of science powered by some seriously fast electronics.
When you really think about it, we've gone way beyond just building walls to block out sound. We are now actively editing our own auditory reality. And that leaves us with a pretty fascinating question to ponder for the future. Now that we can scientifically engineer silence, what's the next sound we'll choose to erase?